Okay, so when we're looking at the transformation of rational functions, here's the general algorithm of the transformations. Now, like we would anticipate, your vertical translation is going to indicate the, now I said vertical asymptote, but actually it should be the horizontal asymptote. So we're going to fix that here. So it should indicate the horizontal asymptote, which means that whatever the value of k is the value of the horizontal asymptote. And then your horizontal translation, or the h value, is going to indicate the vertical asymptote. And with that, we mean that whatever it equals, we have to figure out what x value is going to get that whole denominator to be 0. So let's say we're asked to state all the asymptotes of the following rational function as well as its domain and range. The first thing we're going to do is identify all the proper variables. So I know that the 3 on top is the a, the 5 on top is going to be the k value, and the 4 here is the h value. And so just like in previous transform functions, when the a value is greater than 1, then that means that there's a vertical stretch. So in this case, we're going to say that there's a vertical stretch by a factor of 3. Now, for the translation, the horizontal translation, okay, because that's the only other, or one of the other ones that are here, we can say that since the h, okay, is negative. Now, what do I mean by negative? Because it looks like it's a positive value. Well, remember we would set this to 0. So if I did x plus 4, right, equals 0, and I did x is equal to negative 4, that means that my h value is negative 4. And so what that means is that it'll be 4 units to the left. Now, for the k value, because it's above 1 and has a value of 5, we're going to say that it goes 5 units. It's shifted 5 units up. Now, what that also tells us here, and I'm going to write an extra little set of note here, is that, remember we said that this indicates the asymptotes, these values here. So we know that it'll have a vertical asymptote of negative 4. Since if we plugged in negative 4, that would make the denominator equal 0. And then here, our k value tells us that there's a horizontal asymptote at 5, and positive 5 specifically. So if we're writing our domain here, we would say that for all x values such that x is all real numbers and x cannot equal negative 4. And then for our range, it's going to be something similar. We're going to write, and we're writing this in set builder notation here. So for all y values such that y is equal to all real numbers, y cannot equal 5. Now, in terms of our non-permissible values, which are our vertical asymptotes, that would just be negative 4 as well. Sometimes questions ask you for the non-permissible value, and basically whatever the vertical asymptote is, that's your non-permissible value. Okay, so let's say we're given this equation here. We also want to find the asymptotes and state the transformations that have occurred. So for the asymptotes, that's easy. We could follow the regular rules, which is that we'll find out which value for the vertical asymptote gives us a value of 0 for the denominator. In this case, that is going to be 1. Okay, so you got a vertical asymptote where the equation is x equals 1. And then for the horizontal asymptote, since the degree of the numerator is the same as the degree of the denominator, then we can just do the ratio between the leading terms. So 4x divided by x, and that just means it's going to be at 4. And for our asymptotes, that's good. Now, to state the transformation, the problem is this equation isn't in the correct form. We need, I'm going to write over here, we need it to be in the form of y is equal to a x plus h plus k. Okay, we need it in that format. So what we're going to have to do is, and I'm going to write it in green here, we're going to have to manipulate this equation into this. Where I'm going to write here as, for I guess kind of a second part to this question, we're going to write manipulate the equation so that it is the proper equation. And what we really mean by that is that we need to get rid of the x in the numerator. Now, there doesn't seem to be any strategy here, or factor, I should say, that can allow us to remove the x from the top. What I'm going to do is, I'm going to change the way that this is expressed so that I can eventually manipulate it into the equation that I need. What I mean by that is, imagine I did 4x, and then I kind of write a blank here, and then plus 2, and then that's all going to be over x minus 1. And if I think about what could I do to this equation to give me an x minus 1 at the top so that I can eventually factor it out without changing the actual math of the equation? Well, if I go like this, 4x minus 4, you're like, well, you can't just add, you can't just subtract 4, that's not really there. True. So we go minus 4 plus 4. So we're going to just add it right back so that way we haven't changed the equation. But what that's going to do is, if we can factor this a certain way, we'll be able to get the x minus 1 and then factor it out and remove it from the equation. So now if I write it as two equations, if I go 4x minus 4 over x minus 1 plus 4 plus 2 over x minus 1, I can now factor this out. And the reason is, if I factor 4 out of this equation, I can get 4x minus 1 over x minus 1 plus 4 plus 2 is 6 over x minus 1. And this is good because now I can actually take the x out of the numerator. And now my final equation is 4 plus 6 x minus 1. And this works because now this is my a, this is going to be my h, and this over here is my k. So now I can describe the transformations. That would then give us a vertical stretch of 6, actually by a factor. I'm just going to write factor because remember it's by a factor of 6, not just by 6. So by a factor of 6, and horizontal shift by 1 to the right.